In exercise 2.2, we shall be studying about the roots of the quadratic equation. What are the roots of the quadratic equation? The values of the variables, for example x or y or z or p, which satisfy the quadratic equation are called the roots of the quadratic equation. Roots are also called by the names zeros or solutions. They are basically the answers of the quadratic equation. Now we know that a quadratic equation has a standard form of ax square plus bx plus c is equal to 0, where a is not equal to 0. We have studied this in the previous video. So as a quadratic equation has a degree of 2, this is the degree of the quadratic equation. It means it has a maximum of 2 roots. It means there are at the most 2 solutions. So there could be 2 roots or 2 solutions, or there could be just one solution, or there could be simply no solutions. Now a quadratic equation looks like a U shape, something like this, against the graph. So this point where this quadratic equation intersects with the x-axis is called the root. So we can see there is one root over here and there is another root over here. So there are 2 roots, and over here this quadratic equation just intersects at one point. It's like a tangent. So there is just one root. Or it may not at all intersect with the x-axis. So over here there are no roots. So now let's understand how to solve the sums with respect to these problems. Have a look. Determine whether the given values are the roots of the equation or not. So as we can see, this is a quadratic equation, x square plus 3x minus 4 is equal to 0. So what we need to do is, we need to put the values of x as 1, then minus 2 and minus 3, and see whether the LHS and the RHS are equal or not. So let us start. So first of all, we shall be putting the value of x as 1. So we'll write substituting x is equal to 1. So we shall write the left hand side is equal to, now the left hand side means anything that is to the left side of the equal to mark. So this is the left hand side. So we shall be writing the left hand side, x square plus 3x minus 4. Now what we are going to do is, we are going to put x is equal to 1. So wherever you see x, just put a 1. So 1 square plus 3 into 1 minus 4. So that is equal to 1 square is 1, 3 ones is 3, minus 4. So 1 plus 3 is 4, 4 minus 4 is 0, and that is exactly equal to the right hand side. So we need to say that, therefore, x is equal to 1 is the root. Root means the answer, the solution, the 0 of the quadratic equation. It is as simple as that. Now let us substitute x is equal to minus 2. So I'll just do it over here itself. So wherever you see x, just need to put a minus 2 and let's see whether it's a root or not. So substituting x is equal to minus 2. Again we need to write LHS is equal to x square plus 3x minus 4, and then we'll substitute minus 2 the whole square plus 3 into minus 2 minus 4. Now remember, the square of a negative number is positive, not negative. So minus 2 square is 4. 3 into minus 2 is minus 6. So it's minus 6 minus 4. So you can see 4 minus 4 is 0, and we have a minus 6, and minus 6 is not equal to 0. So over here LHS is simply not equal to the RHS. So it means that x is equal to minus 2 is not the root. Is not the root of the quadratic equation. So if it does not satisfy, it's not a root. If it satisfies, it's a root. So let's continue. Third time, we shall substitute minus 3. So we'll write substituting x is equal to minus 3. So minus 3 square plus 3 into minus 3 minus 4. So minus 3 square is a positive 9. Then we have 3 into minus 3 is negative 9. Remember, a positive number and negative number when multiplied will give a negative answer. So 9 minus 9 is 0. And we have a minus 4. And RHS is still a 0. So we can state that the LHS is not equal to the RHS. Therefore, minus 3 or x is equal to minus 3 is not the root. It's important to write this of the quadratic equation. Let's have a look at the other one. X square plus 5x minus 14 is equal to 0, and the values of x are square root of 2, minus 7 and 3. So again we'll say substituting x is equal to square root of 2. The left hand side is anything to the left of the equal to mark is the left hand side. So this is the left hand side. Is equal to x square plus 5x minus 14. So let's substitute. Is equal to square root of 2. Wherever you see x, put a square root of 2. The whole square plus 5 into square root of 2 minus 14. Remember, 5 and then a bracket means multiplication. So square root of 2, the whole square is back to 2 plus 5 root 14. Sorry, 5 root 2 minus 14. So you can see that 2 minus 14 is minus 12 plus 5 square root of 2, and we know this is never going to be equal to 0. So this is not equal to the right hand side. Therefore, x is equal to square root of 2 is not the root. Now let's substitute x is equal to minus 7. So minus 7 the whole square plus 5 into minus 7 minus 14. So minus 7 the whole square is 49. 5 7 is 35, plus and minus is minus, so negative 35 minus 14. So 49 minus 35 is 14, and 14 minus 14 is a 0. So this is equal to the right hand side. So LHS and RHS are equal. So we can state that x is equal to minus 7 is the root of the given quadratic equation. Now let's substitute the last value, x is equal to 3. So LHS is equal to 3 square plus 5 into 3 minus 14. So is equal to 3 square is 9, 5 3s is 15 minus 14. 15 minus 14 is 1, 1 plus 9 is 10. And RHS is not 10, RHS is a 0. So RHS is a 0. So we can state that, therefore, left hand side is not equal to the right hand side. Therefore, the value of x is equal to 3 is not the root of the given quadratic equation. Next sum, 2p square plus 5p minus 3 is equal to 0. This time the variable is p and not x. So we'll substituting p is equal to 1. This is the first value, 1. So the left hand side is equal to 2p square plus 5p minus 3 is equal to 2 into 1 square plus 5 into 1 minus 3 is equal to 1 square is 1, 1 2 is 2, 5 1 is 5 minus 3. Remember, first you need to square and then multiply. So we have 2 plus 5 is 7, 7 minus 3 is 4, and we have the RHS as 0. So we can state that left hand side is not equal to the right hand side. Therefore, P is equal to 1 is not the root of the given quadratic equation. Now let's take the value of 1 upon 2. So we'll write substituting P is equal to 1 upon 2. So LHS is equal to 2P square plus 5P minus 3. So 2 multiplied by 1 upon 2 the whole square plus 5 multiplied by 1 upon 2 minus 3. So let's simplify this. This is equal to 2 multiplied by 1 square is 1, 2 square is 4 plus 5 1 is 5 upon 2 minus 3. So 2 ones are 2 twos are. So we have 1 upon 2 plus 5 upon 2 minus 3. So we have a common denominator of 2, 1 plus 5 minus 3. So we have 6 over 2 minus 3. 2 ones are 2 threes are 3 minus 3 is a 0, and that is equal to the right hand side. So we can state that therefore LHS is equal to the RHS. Therefore P is equal to 1 upon 2 is the root of the given quadratic equation. Now let's take the value of P is equal to minus 3. So substituting P is equal to minus 3, we have 2 into minus 3 the whole square plus 5 into minus 3 minus 3. So we have minus 3 the whole square is 9, positive 9, remember. So 9 twos are is 18. 5 into negative 3 is negative 15 minus 3. So we have 18 minus 15 is 3, 3 minus 3 is 0. And this is equal to the RHS. RHS in all such cases is a 0. So we have LHS is equal to RHS. Therefore, the value of P is equal to minus 3 is the root. So we saw in this particular problem that P is equal to 1 was not a root, but P is equal to 1 upon 2 was a root, and P is equal to minus 3 was also a root. So in this particular equation there are only two roots, 1 upon 2 and minus 3, and all the other values will not give you the answer, will not give the LHS and RHS equal. Now let's look at the other question. If one root of the quadratic equation x square minus 7x plus k is equal to 0 is 4, find the value of k. So we have been told that one root of this quadratic equation, which means the value of x, root means the value of x, the solution. If one root of this quadratic equation is 4, means if one of the values of x, remember x can have two values at the most. So if one of the values of x is 4, what is the value of k? So it's a very simple one. What we'll do is we'll put x is equal to 4 because that's one of the roots in this equation. And see what do we get. X square minus 7x plus k is equal to 0. So instead of x we'll write 4. So 4 square minus 7 fours are plus k is equal to 0. So we have 4 square is 16 minus 7 fours are is 28 plus k is equal to 0. Plus and minus is minus. 28 minus 16 is 12. Sign of the greater one is negative. Plus k is equal to 0. Minus 12 goes on the other side. It becomes a plus 12. So we have k is equal to 12. Let's have a look at the last sum. State whether k is the root of the given equation. This is the given equation from year to year. Y square minus bracket open k minus 4y minus 4k is equal to 0 or not. We need to determine whether it's a root or not. This time we need not find any value. Means we'll put y is equal to k because this time the variable is not x but y. So wherever you see y, we're going to put k and we are going to determine whether LHS and RHS are equal. So remember, whenever the question is to determine whether it is or not a root, we need to do the LHS RHS. So we'll say substituting y is equal to k. And let's see what is the LHS. The LHS is equal to y square minus k minus 4y minus 4k is equal to 0. So we have, so we'll put y is equal to k. So k square minus k minus 4 multiplied by again k minus 4k. Oh, I beg your pardon, we should not be writing is equal to 0. So let's continue. Is equal to k square. Now this k need to be multiplied to both these terms. So we have a minus k square, minus and minus is plus 4k, minus 4k. So remember, we should not put it is equal to 0. So k square minus k square is 0. We have a 0 over here. And 4k minus 4k is also 0. So 0 plus 0 or 0 minus 0 is a 0. So that is exactly equal to RHS. This is the RHS, which is also 0. So whenever we have LHS is equal to the RHS, we can state that y is equal to k is the root, or simply k is the root of the given quadratic equation. I hope you understood. Thank you for watching.